Welcome friends to the another session on digital electronics. In this session, we will be discussing about the conversion of octal numbers. We will discuss what is the necessity of conversion of octal numbers and how octal numbers are being converted into equivalent numbers in other number systems such as decimal, binary, and hexadecimal number system. Friends, as you know that you are viewing this session on my YouTube channel, Learn with Prakash Kanade. And do not forget to subscribe to the channel. So let us start our session. You will find that nowadays we have been using various applications of IT in the various fields of our life. You will find that we are using IT in the travel field. We are using information technology in education. When I'm delivering this session to you, it means that we are using IT. We are making the use of IT. We are using IT in finance. Many of the government services are making the use of IT. Publishing a book nowadays is being done by using computers or by using IT. You will find that in the field of science, in the field of manufacturing, in the field of healthcare, almost everywhere we are making the use of IT. You will find that whenever we want to develop an application in IT, then we need to write programs, appropriate software programs. And these programs need to make use of various numbers. You will find that octal number system is one of those number systems that can be used in IT application development. Any programming language such as C programming language will allow us to make the use of octal number system. You will find that there are 4 number systems: decimal, binary, octal, and hexadecimal. A number from one number system can be easily converted into equivalent number in another number system. When we convert the number from one number system to another number system, then you will find that what exactly we are doing is that we are changing the base of the number. Now, why should we go for the conversion of octal numbers? You will find that the biggest advantage with octal numbers is that its binary representation is very easy. Or you will find that any given binary number can be very easily represented in its octal form. The another main advantage of octal number system is that octal number system makes use of less number of digits than that of decimal or hexadecimal number system. In decimal number system, we need to make use of 10 digits from 0 to 9. In hexadecimal number system, there are 16 digits from 0 to 9 and A to F. But in case of octal number system, only the numbers from 0 to 7 are used. So naturally, when there are less number of digits, it means that the computation is less. And it means that the computational errors are also reduced. So octal number system can be used whenever you write any IT application or whenever you write a program by using a programming language like C, then you will find that it is possible that you can use octal numbers within your program. In Unix, you will find that the file permissions are written by using only octal numbers. You will find that the Unicode is there. Unicode is just like the ASCII code, where almost every symbol can be converted into binary form. This Unicode transformation format 8, shortly it is being called as UTF-8. You will find that this code makes the use of octal numbers. And therefore, you will find that in comparison with the decimal number system or binary number system or hexadecimal number system, octal number system is comparatively less used, but still it can be used. And when we use it, we need to convert the octal numbers into the numbers in other number systems such as decimal, binary, and hexadecimal number system. So in this session, we'll be discussing how octal numbers can be converted into equivalent decimal number, binary number, and hexadecimal number. So the first conversion that we are going to discuss is octal to decimal conversion. Suppose you have been given an octal number and you want to convert this octal number into equivalent decimal number. So how can you do it? It is very simple process. What you have to do is that for the given octal number, you have to write down the weight of the octal digit, and it is in the powers of 8. So if the octal number consists of a octal point, then you start from the octal point to the left hand side, the weight will go on increasing. And when you start from the octal point to the right hand side, the weight will go on decreasing. Then you have to take the product of each octal digit and its weight. And then in the final step, what you have to do is that you have to sum all such products together to get the decimal equivalent of the given octal number. Say for example, we have been given a octal number 724 and we want to obtain its decimal equivalent. Then how can you do it? This is a simple process. This is a number which is containing only integer part. It do not contain any fractional part. And therefore what I will do is that I will write the weight for each octal digit. Now I will start from the octal point. So here it is being assumed that the octal point is being present. And therefore the weight of this 4 is 8 to the power 0. The weight of this 2 is 8 to the power 1. And the weight of this 7 is 8 to the power 2. Now I will take the product of 4 and 8 to the power 0. 8 to the power 0 is 1, and therefore 4 into 8 to the power 0 is 4. 2 into 8 to the power 1 is 16. 8 to the power 2 is equal to 64 into 7, which is equal to 448. And when I sum all such products together, then I will get the equivalent decimal number, and this equivalent decimal number is 468. Now let us go for another conversion. Now here we will convert the octal number into its binary equivalent. An octal number can be very easily converted into a equivalent binary number. And this process is only a one-step process. That is, what you have to do is that for each octal number, you have to write down a 3-bit binary equivalent for each octal digit. And when you do so, then you will find that you will get the binary equivalent. So in this process, we need not to multiply anything, or we need not to divide by anything. Say for example, we have been given a octal number 35.346 and we want to obtain its binary equivalent. So how can we do it? Now first of all, I will write this number 35.346. Now what I will do is that starting from this octal point, I will write first of all a 3-bit binary number for 5. So for this, I will use this table. So when you refer to the table, you will find that the octal 5 will have a equivalent binary 101. Similarly, I will write the binary 3-bit binary number for the octal number 3, and it is 011. From this table, you can easily see that this number is 11. But since we want to write a 3-bit, we will put here a 0 and it will be 011. Similarly, for this 3, the binary equivalent will be 011. For this octal 4, the binary equivalent will be 100. So for this 4, the binary equivalent is 100. And for this octal digit 6, the binary equivalent will be 110. So for 6, the binary equivalent is 110. So we need to make use of this table in order to write the corresponding binary number for each octal digit. And then we will get the corresponding binary equivalent number. So you will find that for this given octal number 35.346, the binary equivalent will be 011, 101, 0.011, 100, 110. In the similar manner, you will find that it is possible that we can convert the octal number into an equivalent hexadecimal number. Suppose we have been given a octal number and now we want to convert this octal number into equivalent hexadecimal number. So how will you do it? This conversion is a two-step. In the first step, we need to convert the given octal number into binary form, and then you need to convert the binary number into hexadecimal equivalent. So in the first step, what we will do is that we will obtain the binary form of the given octal number by writing the 3-bit binary number for each octal digit. Then we will try to convert it into hexadecimal number. So for such conversion, again, we have to start from the binary point to the left-hand side, and we will make the group of 4 binary bits. If your binary number consists of the fractional part, then again you have to start from the binary point to the right-hand side, and again we will make the group of 4 binary bits. Now you will find that each group is being represented by the hexadecimal digit. Now let us understand this process with some example. Suppose we have been given a octal number 175 and we want to obtain its hexadecimal equivalent. So how do you do it? This is the number 175. Now in the first step, what we will do is that we will write the 3-bit binary number for each octal digit. So for 5, we will write 101. For 7, we will write 111. And for 1, we will write 001. So by using this table, we can easily write the 3-bit binary number for each octal digit. Then we will make the groups of 4 binary bits. Now since this number consists of only integer part, we will start from the right-hand side to the left-hand side. So we will start from here and we will make the first group, and that will be 1101. Then we will make the second group, and the second group will be 0111. Now there is only 1 0, it is being left, and therefore I will add 3 more zeros so that this number will be 0000. Now what I will do is that again I will represent each 4-bit group by a corresponding hexadecimal digit, and for this again we will use this table. So 1101 is to be represented by a letter D. 0111 is to be represented by a digit 7, and 0000 is to be represented by a digit 0. And therefore you will find that this octal number 175 has an equivalent 07D, but 0 is the leading 0. I mean, it can be omitted, and therefore we can write this result as 7D hexadecimal. So thank you friends for viewing the session. Hopefully you have understood what are the octal numbers, what are their uses, and how octal numbers can be converted into equivalent decimal, binary, and hexadecimal numbers. In the next session, we will see how the hexadecimal numbers are converted into equivalent numbers of other number system. Thank you for viewing the sessions. If you have any queries or if you want to ask any questions, then you can always write to me. Thanks all for viewing the session.